Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try and answer this question yourself, pause the video now. If you got the answer B, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So, quark combination of a particle is strange and anti-up. Which is true for this particle? So we need to look at the properties that a strange and an anti-up quark would produce. So you need to look at your data sheet. I've already cut and copied the relevant page from the data sheet, from the AQA data sheet. So first thing is baryon number of +1. Well, a strange quark has a baryon number of +1/3, and an anti-up has a baryon number opposite to the up. All the properties of an anti-up quark are the opposite properties of the up quark. So strange quark, baryon number of +1/3, anti-up, baryon number of -1/3. So overall, this has a baryon number of 0. So does it have a baryon number of 1? No, it doesn't. A charge of -1.6 times 10 to the -19 coulombs. Well, strangeness has a charge of -1/3. An up quark has a charge of +2/3, but of course it's an anti-up, so it's got a charge of -2/3. -2/3 plus another -1/3 means it's an overall charge of -1, which is the same as the charge on an electron. That's correct. So we could stop there. Let's go and see why it's not a pion. Well, a pion is otherwise known as a pi meson. Pi mesons always have strangeness of 0. Here we've got a strange quark with strangeness of -1, an anti-up, which will also have a strangeness of 0, same as the up. So overall, there's a strangeness of -1 for this particle. And as I said, a pi meson always has a strangeness of 0. It has a strangeness of -1/3. No, we've just established it's actually got a strangeness of -1. So that's not true either. So the answer is B. I hope you found this useful. If you did, please press the like button. All comments will be welcome, and I hope you'll share and watch more of these videos in the series.